All right, so yeah, so for 9, 10, so for example, number 9. So real quick, I'll just whip out number 9. Number 9, you would just put into your calculator, this problem right here, 2, 3, 5, 8, 12, 20, R, R, E, F. Right? Remember, like I said last time, don't worry about the part that says solve by hand. It won't say that on the real exam. On the real exam, it doesn't say solve by hand.
But on number 9, wouldn't it be just easier to divide 8 by 4 and then it'll equal the first one?
Oh, yeah. Good observation. Divide the whole thing by 4, huh? And then, so those are infinite solutions. Huh? Yeah. Yeah. Oh, yeah. How do you know on RREF? When you do RREF on that, don't you come out with some kind of matrix that has, like, all zeros? Is that what you get?
On that one, it would.
Yeah. I think the bottom one would become all zeros on that thing. Remember what all zeros mean? Infinite. Infinite solutions. Yeah. But you can do that by hand method. You're right. Edward, right? Edward? Good observation. Yeah. All right. We good with that? Let's go. Now, 12 and 13 I talked about. Did you get it when I talked about it last week as well? Right? So 12 and 13. So when you look at, so I'm just saying, hey, the big old explanation here basically says, hey, you did RREF, and here's what you got. I'm just asking you to interpret answers there, is what I'm doing. So when you do your calculator and the RREF comes out to be this big old matrix, what does that answer mean?
Infinite.
That one again is infinite because of these zeros right here. So that one's infinite. But then I asked you on this one in particular to say more than just infinite, right? The other one we did a minute ago, infinite was fine. But on this one I'm saying, hey, say more than just infinite. Go ahead and tell me, I do all this talk about if it is infinite, then say that, but solve for x, y, and z, w, and give 2 particular examples, right? So I did that last time. Are we okay with that? That makes sense, right? Let me just, again, really quick. That means if you take these numbers, well, here, I can just stick the letters above it. That means, remember, the first column is x, the second is y, the third is z, and the fourth is w, right? So then if you, I'm kind of writing over the top of things there, but so that's what it means. So these are x's down here, these are y's, these are the z's, these are w's. So that means the first equation is saying 1x plus a bunch of zeros plus 3w equals 13. That's what that first equation is saying. Are you tracking with me on that? The second equation is saying 1 times y is -8, right? Because it's just 1 right here next to the y. See how I'm coming up with that? Please ask me afterwards. If you're having trouble, please ask me. I am glad to help. Hang out for a few minutes. Like I said, I know there's this thing these days that says if you ask questions, you're bad or dumb, or, well, then I'm dumb. Because I asked questions. I had lists of questions for my math teachers and science teachers all the time. So I even went to my sociology teacher's office one time, I remember. Anyway, I was always hanging out with my teachers. So please ask me. If you're having trouble with the calculator or with anything, please hang out for just a minute. Probably 1 minute hanging out. I can save hours of your life and lots of points. I'd be glad to. I'm paid to help and glad to help. All right, so, and then the third one is 1z minus 2w equals 6. Do everybody see how I'm coming up with that? I'm just looking at the right. This is the first. So it's x, y, z, w. So that's 1y minus 2. I'm sorry, 1z minus 2w equals 6, right? So I just write those 3 equations, and then I solve for x, y, and z. Actually, y's already done. Nothing more needs to be done with y. But x, you need to jump this over. So we get x is 13 minus 3w, and z, we need to jump this over. So z is what? 6 plus 2w. So boom and boom. So we got x, y, and z. And now we just plug in what we need there. Actually, let me show you what we need. So these are the 3 things they want. And then at the last part, they say give 2 particular examples. What that means is you let w be 0 and you let w be 1. And you plug in and find out what x, y, and z are. You've already got w. You're choosing w. Right? You see what I'm doing there? W can be any number. So if I choose w to be 0, what is x? From over here, right here, x is 13 minus 3w. And so if I'm plugging in 0, let me get a little more room here. If I'm plugging in 0, then that's going to be 13 minus 3 times 0, right? I chose w 0. So x is just 13. Y is -8, nothing to do for y. So there's x, there's y. Z, What's z? It is 6 plus 2w. So that is 6 plus 2 times 0, that's just 6. So there I have for w0, I have x13, y negative 8, z6. That's one particular solution involving 4 numbers, right? That is the solution, if this helps you. It's x, the solutions are x, y, z, w. That's the solution. 13, negative 8, 6, 0. That's one answer to the original system of equations. And then you can do a second one, which is what I'm showing right here. If I show it, so okay, now let w be 1. You can let w be any number. What is x going to be? 13 minus 3 times w. 13 minus 3 times 1, what's that, 10? Y is always negative 8, nothing to do there. Z is 6 plus 2w. So that's 6 plus 2 times 1, what's that, 8? So there's another particular answer, which is what? X is 10, Y is negative 8, Z is 8, W was 1. There's another X, Y, Z. So there's one answer, there's another answer. And we could go on and on. See what we mean by infinite? You could just, any number you want to pick for W, there's going to be another 4 numbers that solve the original thing. Does that make sense on that? Is that good? So how do we know it's infinite? Zeros across the board. On one of the rows has zeros all the way, and then we just put in the x, y, z, w, write the equations, solve for x, y, and z, and then choose w0, w1. All right, how about the next one? So I'm doing this again quick, because I did do it last time. How about this one? What do we know about 13? How do we know no solution right away? Right there. Yeah, because think about what that says. Now that you know the x, y, z, w thing, think about what that says. That says 0x plus 0y plus 0z plus 0w plus 0 whatever other letter you want, v or whatever, equals 1. That says 0 equals 1. 0 doesn't equal 1. Do you see why anytime you have a bunch of zeros and a number that's not 0, that's craziness. That's no solution. Right? The other one, this says 0 equals 0, which is dumb but true. Right? It's not false. But this one, that's just plain false. No way, no solution. See how that's giving us falsity? See when you have all zeros, right? All zeros equals a number that's not 0. No way. That's always no solution. Done. Nothing more to do. All right, good. I think you're all good on those, huh? So then how about number 15? So definitely have those in your 3x5 card. So number 15 now. 15 is just set up equations, right? It says right out there. I'm trying to give, this is what I'll do on the real test too, exact same format. A lot of problems, but none of them are too long. Meaning I'll have you do like when we did this in the homework, we set up the equations and solved them. I'm having you just set up, right? Only write out the systems, don't solve. Just because that way I can test your ability to do lots of little things without using up all your time on that, right? So I'm giving you just a setup. That's just a setup question. So I'm just testing, can you set up? Well, okay, let's see. X, Y, Z are the 3 models. So remember how you do that? You put those across the top, X, Y, Z. And then what does it say? Each model requires 3.2 hours of electronics work. This is each X. So electronics, 3.2. Assembly is 2.8, and 4.4 hours of quality, whatever quality assurance, that was 4.4. So that's for X, right? And then you do the same thing for Y, 2.8, 5.2, 4.4. And the same thing for Z. Whoops, I made it bigger there. Same thing for Z. What is Z? 2.4, 3.2. And 5.2. So there's Z. And then it says 328 for electronics. So that's over here, because that's electronics, right? And then 452 for assembly. That's over here for assembly. And then 568 for quality. That's over there. And that's it. Then you just stick X's here. And Y's here. And Z's here. Right? And equal signs. And plus signs. And we got it. Isn't that good? Just make it like a big old table. Right? always put your x, y, z across the top. Always put your 3 different things you're trying to find right across the top. And we're done. There's the 3 equations they wanted. And actually, you know how to solve them, huh? With the calculator, it'd be really easy. You would just type in those numbers and hit RREF, and boom. So really, I'm not saving you that much time, huh? We'll have those on other problems to do. Is that good to there? You good with setting up that word problem? Okay, so there's number 16. Alan invests $15,000 in 3 different ways. So I'm doing number 16. He invests one part in mutual funds, invests another, how much did he invest in each way? It's good to jump down and find the actual question. That kind of is a good place to start. It's all, there's only one question mark up there, right? It's that last sentence. 3 different ways. What are his ways of investing? Mutual funds and government bonds. So I'm going to put that across top. Mutual funds, then the bonds, and what's the third way? Oh, bank, just straight in the bank. Okay. So those are the 3 ways. Those go across the top. Remember how the X, Y, Z? So this will be my X, my Y, my Z, or whatever you want to call them. But you always put those across the top. Do you see why I don't put those down the side? That's what I'm saying. Everybody catching that point? I'm saying when you do these big old word problems, take whatever the 3 things are, or 2 things, or 4 things, or whatever, that they want you to find, and put those right across the top. X, Y, Z, mutual funds, bonds, and bank, whatever. And then just make your big old table, right? Or your matrix, or whatever you want to do. What's it saying? So Alan, 15,000, 3 different ways. It's 11%. So this is going to be 0.11 for this kind, X, and it's going to be 7% for the Y, it says, and writing over the top of it there. Maybe I should move that down. X, Y, Z. So it's going to be, I'll move it down. 11X plus 0.07Y plus 0.05Z equals what? Total return 1170. What do you do with this 15,000? Yeah, that's the X plus Y plus Z is 15,000. Am I on the screen with all that? Yeah. So this is the so remember in money equations, you always have one of them where you got the percentages, right? And then the other one that's regular, no percentages. Is there any other information I haven't used? Twice as much in the mutual funds, that's X, as in the bank, that's my Z, isn't it? Now remember what you do when they say one thing's bigger than the other and you want to make them equal? Who do you bring up? The small guy. So they're saying he invests twice as much in X. He's saying, hey, X is twice as big. So if I want to make them equal, who do I got to double? Z, right? So X is 2Z. That makes sense. You got to double the small guy because X already is twice as big, they're saying. That makes sense? X already is twice as big. So you got to double the small guy if you want to make them equal, if you want to achieve equality. Does that make sense there? Monique?
Okay, so you know how you have your 11,700, the 1,170 line above. Does it matter which one is on top of it?
Oh, it doesn't. Yeah, good question.
I had mine written a different way, but I still got the answer.
Yeah, you can put these 3 equations in any order.
Okay.
Yeah, it doesn't matter at all. That's all I want on that is just those 3 equations. Don't need to solve anything else from there. Is that good? Does that make sense? I'm hoping this time is going to make everybody do very well on the test. That's my hope and desire. Some were already ready, I know. Sorry if you were all ready to go. That's why I had mixed feelings about doing this. All right, but I was out of town, so. All right. Now, 18 usually fools people. Oh, did it come? It's not. Oh, yeah, it's on the screen. It's not on my screen. There it is. All right. So, how do we do number 18? Well, this is about two matrices. It says 3 different high schools plan to order the same 3 books. School A is going to order 50 books. 50 of book 1, 40 of book 2. So, okay, we have school A. They're going to order 50, 40, and 40, right? School B is going to order, this is book 1, book 2, book 3. School B is going to order 40 and 30 and 20. 40, 30, 20. And school C is going to do 80, 60, 40. Right? Getting right here, 80, 60, 40. 80, 60, 40. So that's like a big old matrix, isn't it? That's a 3x3 matrix. So you can just make that into a big old matrix like that. And then now the other matrix is this money matrix. $15, $20, and $25. Now, there's a few options for how to do that other matrix. You guys all with me to here? I could do it the following way. I could take the what is it again? It's $15, $20. You don't have to put the dollar signs. I'm just wasting time there. 15, 20, 25. This is what when I was gone. So this is why like I felt kind of bad testing you on this. I know Mr. Karambakis went over the basics of how to do the calculator and everything, but he probably didn't go into the detail that I'm into. I'm kind of into this right here. That's why I'm testing on it in particular. I mean, it was in your homework, but I'm really into it. So you can, there's for sure one of these on the real test we'll take next time. Yeah. Yeah, let's talk about it. So the reason, first off, I'm really into this is because I'm just thinking, what am I doing for these people to help them in the real world? Because in the real world, computers do all this stuff, right? I mean, let's be real. Computers do all this stuff. That's why every time I can, I let you use the calculator. But although that is true, computers do it all, the second thought, which a lot of people have, is not true. And that is, therefore you don't need to know anything and you just hit the buttons and it goes. No, computers are not smart. They're just fast. You have to be the intelligent operator that knows. What I mean is, yeah, you're right. Computers will multiply all the details. I don't care about you multiplying by hand and everything. But how do you tell it to do it? What I mean is, do you put this matrix sideways on the right side, or do you do it vertical? There's nothing in the words that tell us otherwise. Should we do it vertical on the right side? It matters. That's different. Or should we put it on the left? Should we put it sideways on the left? Or should we put it vertical on the left? How should we tell the computer to do it? Only one of those 4 ways is correct. And the computer will crank out garbage any which way. It doesn't know what the world's all about. Computers know nothing. They just are fast with the numbers, right? So if you're not an intelligent operator to know how to tell the computer to do the thing, you're going to get garbage, like they say, garbage in, garbage out. You're just going to get garbage out, and you're not going to realize it. So that's why I'm into this, because I think it's really what's most valuable. So let's talk about it. How do we know among those 4 options? Do you guys understand the 4 options? I could either put this thing sideways on the right side or vertical on the right side. Or I could put it sideways on the left side or vertical on the left side. There's 4 options to times, right? We're going to multiply these 2 matrices, and the one in the middle, that's good. We know he's what he is. But should I put this one on the right side this way or vertical? Left side this way or vertical? Only one of those 4 options is correct. How do you know? Well, you got to know what matrices do when they multiply. Even though I'm not requiring you to do the whole thing by hand or anything by hand, you really have to still know what the thing's doing to be able to know the answer to this question. So first off, there's 2 things you need to know. There's the size rules. Are you good with the size rules? But that's only half the battle. That'll leave us with 2 options still, and you got to know even a little bit more than that to narrow it down. First off, the size rules. This is a 3x3 matrix, right? This matrix, is this a 1x3 or is it a 3x1? If you don't know for sure, you're in trouble. You don't know what you should know. Is this one a 1x3 or a 3x1? It's down first, so it's a 1x3. Yeah, so you got to know that. That's absolutely essential. I don't know if Mr. Karambakis beat the drum like I am, but that's really important. It's down by across. I always beat the drum when I lecture on this section, but I was not in town at that time. So I want to make sure you got the message clearly. It's down, it's opposite of graphing, huh? We're going to graph today, and once I get done with this review. Remember graphing? It's across first, then up. Remember? So this is opposite. Matrices is down first, then across. So this is a 1 by 3, not a 3 by 1. And this one down here, this one's a 3 by 1. And this one over here, whoops, I kind of wrote them in the wrong. I'll just put the 3 by 3 here. This one is a 1 by 3, and this one's a 3 by 1. So he's down first, then across, right? So how do we know which of those is right? Well, can you multiply a 3 by 3 matrix with a 1 by 3 matrix? What's the rules for when you're allowed to multiply matrices? The two inside numbers have to match. Do you know that? You must know that. You have no shot on this problem. The two inside, and when you multiply matrices, this number and this number must be equal. Inside must be equal. Or your calculator will just tell you error. If you try to multiply two matrices where the size numbers in the inside are different, it'll say, I don't know what it's, error, can't do it, whatever it says. It just won't do it. See, if you're an operator trying to tell a computer or something to do that, if you're a admissions and records officer and you have a student matrix of all the students at the school and a financial charge matrix and you don't know which way to multiply those and you tell it the wrong way, it's just going to go, and what's wrong with this computer? Well, it's the operator, right? Doesn't understand really what's happening. So that makes sense? So this is a no and this is a yes for now. This one's out because you can't do a 1 by 3, but you can do a 3 by 1 because these inside numbers match. Remember that? So the inside numbers have to be equal for it to be doable. So this one's a maybe. Turns out it's not really going to be the answer, but it's a maybe for now. It's passed the first test. How about these guys? Can you have a 1 by 3 on the left?
Yeah.
Now, you understand? These were options for the right side. Now I'm going, and among the options for the right side, the 1 by 3 was out, the 3 by 1 is yeah. The two inside numbers match. How about options for the left side? Can you have this 1 by 3 with a 3 by 3? Do the inside numbers match? Yeah. That's a option. Can you have a 3 by 1 with a 3 by 3? No. Inside numbers. No. He's out. So we're down to two options. You can either do a sideways matrix on the left, or you can do a vertical matrix on the right. Both will fit the size rules. But there's more to it than that. So we good so far? So how do we know which of those two options will give us what we really want? Questions to that point? Is that making sense? So you check the size rules. Okay, so let me go with the two options, and we'll talk about just those two. Let me kind of clean up what we got here. All right, so let's try the one that's actually not the answer. The one on the right, which would be a vertical matrix on the right. What were those numbers again? 15, 20. I can't see anything up here. 15, 20, 25? Is that what they were? All right, so 15, 20, 25. Is that right? Yeah. Okay, good. So now what is now? Now is when you got to realize what are those things? What is that 15? That's $15 for book one. Book that's supposed to. I wrote book backwards. I am dyslexic. And $20 for book two, and 25 for those are books, right? Is that what it says? 25 copy. Yeah, book three. Book two's 20. But so you got to think about what those really are. Okay, great. So what? Well, and then you got to know how matrices multiply. There's Roberto, the tutor. He's available for help now that Roberto has hours on Monday and tomorrow, Friday, huh? Friday 11 to 2, and Monday 1:30 to 3:30. He'll be there. All right. So now I know we didn't. We just do them with our calculator, right? But you have to know a little bit about the by hand method. I'm not requiring you to do it by hand all the way, but you have to know a little bit about how matrices multiply, what they're actually doing. The left one goes across, the right one goes down. You've got to know that's what they do. It's like that old thing. Can you rub your belly and pat your head? Coordinate. It's like this, right? The left. So as you look at them, this is all you need to know. Nothing more. Nothing more. I just want you to know what you would need to know as an operator. This one has to go across, meaning I'm going to go 50, 40, 80. And this one's going to go down, meaning 15, 20, 25. That's how they multiply. And they jump. So now, what am I talking about? What does that matter? That means 50 is gonna multiply 15. Is that acceptable? Well, yeah, that's okay. I mean, 50 is a book one kind of thing, and 15 is a book one kind of thing. That looks reasonable. It's the next step that shows us the problem. Next, 40 will try to multiply 20, right? Because as you take a step across on the top, you go down here, right? Across and down. Is that right for 40 to multiply 20? No way. 20 is a book two kind of thing. That shouldn't be multiplying 40, which is a book one kind of thing. Garbage. It'll do it. The computer, the calculator will give you some numbers, and they're garbage. It just took how many books location B wants, how many book ones location B wants, and multiplied it by the price for book two. It's garbage. It's not, the numbers are meaningless. So that's why this is out. If you put it on the left side, it's correct. We don't want to spend forever on this thing, but 15, 20, 25. Left, it's on the left going sideways. Why? Because remember the matrix, now that one's on the left. The matrix that's on the left, bigger, smaller, whatever, the one that's located on the left goes across. The one on the right goes in. Now this guy is going to be the, now this guy is going to be the go down over here. For him, I'm going to be going down because now he's the one on the right. Do you get an idea? That's how matrices multiply. The one that is sitting on the left always goes across. The one that is sitting on the right always goes down. Start in the first row. So is that going to do the right thing? It will. 15, remember that's book one, is going to multiply 50. That's good. The first step is always good. You got to check the second step, really. 20 is going to multiply 40 because he's going down. Is that right? Perfect. That's book two. 40 is book two. And 20 is book two. That's book two with book two. Perfect. That's the right thing. So here's the answer I want you to show me. That this one goes sideways on the left. That's the whole trick. I mean, we all know about the 3 by 3, but where does the 1 by 3 or 3 by 1 go? Left side, right side, vertical, sideways? What is it? 4 options. That's the only right one. Make sense on that? I'm assuming Mr. Karamakis didn't get into all those details. That's just kind of my pet peeve. I just think it's what's valuable out of this class. Not all the adding and subtracting. Computers will do all that for us. But how to be a wise operator of matrices. All right, good. I want to make sure you're okay. So, there will be a word problem, a couple of word problems like this, and these are hard. So, okay, so there's court side. What are the three things we're talking about? Court side seats, end zone seats, and balcony. It's always good to identify what the things are we're trying to find first off. So court side, end zone, and balcony. Okay, those are the three variables. And first, 15,000 seats. So what doesn't that mean? They add up to 15,000 total. Total number of seats, right? And then you bring the money in there. $8 for the courtside seats. End zones are 6. And balconies are 4. And the total is what, $76,000? All right. And then half the court side, so we got those two equations, and then half the court side, that'd be half C or 0.5 C, it doesn't matter. Half the court side and the balcony, add up the balcony. If they're, if half the court side and balcony, that's supposed to be half of both, huh? I'm messing up. Oh, and I'm probably supposed to put the money in there. I'll check it out in a minute. And all the end zone, then they're telling me money, so I got to go back and put money in those. So next to this C should be what, 8, and this should be a 6, and the end zone.
You got the B and the
Oh,
E.
they switched them on me. They're being tricky. I didn't see that. Yeah, it's got to be a little tricky. That was right, huh? 8 times a half, and this was, what's the B? B is $4. 4 times a half, and this is 6 times Z. Yeah, see how I had to put the money in that one?
You have your E and your B under the wrong. You need to switch your B and E.
Oh, am I messing up again?
Just on the third one.
On the third
What's wrong?
You
It says half the court side and balcony.
You put it down like you read it. Just
If half the
switch
court side and balcony and all.
It's C, E, B on the last line instead of C, B, E.
Oh, as far as putting it in a matrix, you mean? Right. I'll fix all that in a second. But is everybody okay with just the fact that that is the word problem? You're right. Before I put it in the matrix, I have to switch them around. Right, is that good? So, because half the court side and half the balcony, but you gotta put the money in for those.
Doesn't your balcony go right there? Or you-
Yeah, I'll have to switch them
Oh,
before I
okay,
type it in the
gotcha.
matrix. Yeah, I'm just saying, this fits the words.
Okay.
But yeah, before we go to the matrix step, we gotta switch them around. Is that making sense on there? I had to put the money, because it's a money statement, right? Just like that one was a money. The 15,000 was not money, that was just numbers. Yeah, so half the 8, so let's fix that one. That should be what, 4C, and, oh, I should switch this one here, 6E, and put this one here, 2B is 44,000. Yeah, then just put it in a big old matrix, right? Just, come on, what's that thing doing? Just put it in a big old matrix. Get rid of that up there. And then just big old matrix, and it'll be, so this is 1, 1, 1, 1, 1, 1, 15,000, and 8, 6, 4, 76,000, and then this is this one. 4, 6, 2, 44,000. And do the RREF. Yeah, I know I said inverse matrix. I don't care how you solve anything. RREF is easier. Just hit RREF. If you want to do the inverse matrix thing, you can. Just put that in, hit the buttons. Yeah.
What exactly is RREF doing? Is it setting an equal one?
It's a big old complex thing. It's called reduced row echelon form. And it's a big complex thing that I used to make people do back when I was a mean teacher. And what it is, yeah. You want to see it for, I'm going to 30 seconds just to answer your question faithfully, but not waste our class time. 111, 15, 15. You really don't want to know. 864, 76,000, 864. You know what you want to see? Do the show me an example on Math Excel. They're doing it. And yeah, you'll see 15 steps that your calculator's doing for you. I'm trying to build up your thankfulness for my teaching. Are you more thankful now? 462, 44,000. 462, 44,000. All right. Anyway, come on. So, then I'm messing up. I'm forgetting. Yeah. So then you got to take this big old thing. You got to put stop that. Put a line there, and then put a bunch of zeros and ones like this. Ones down the diagonal. Oh, and you got to put in another row or something, don't you? Oh no, I'm getting confused. That's for an inverse. I haven't done this by hand for so long. I know now. Now it's all coming back slowly, painfully. All right, so you need to then take this thing and change it into what's called row-reduced echelon form, meaning by legal row operations, and we're not really talking about what that is, you got to eventually make the thing be ones down the diagonal with zeros everywhere else, and then the numbers out here will be your three answers. That's called reduced row echelon form. The calculator does it for you automatically. You've got to do a bunch of legal steps. Like, for example, you've got to take this equation. This is an equation, and you got to multiply it by -8, and then add it to the bottom equation. See, -8 times 1 will be what? -8, add 8 is 0. It puts a 0 there. You force the 0. But then you got to do this one times -8, and this one times 8, and this one times 8. And then you got to add them. So -8 plus 6, this would be 2, and then da-da-da-da-da. Then you got to multiply through a half. It's just a million ugly steps. Yeah, I had to do it when I was a student, and I used to make students do it my first 5 or 10 years of teaching. Then I thought, oh man, everybody's failing. How are we doing on time? I'm using up a lot of our time. Let's see. Let's see this one. Okay, yeah, so 22. How do you solve for x here? Yeah, you take the 2, 2, 0, -4, -3, 2, 0, -3, -5, and do the inverse of it times the B matrix. And just do it on your calculator, right? It's supposed to be it. Yeah, that's right. Does that make sense? It's the inverse of A times B. That good? Or, you know what you could do? RREF for this thing. You could just stick it all in one. I hope I'm not confusing you. You could just stick it all in one big thing. I don't care how you do it, as long as you know they're both doing the same thing. You could just stick it in the right, stick that 2, 12, -11 on the right side, and just do RREF. Do you see the difference? Yeah, maybe it is worth it that I spend a minute talking about the difference between these two, right? So when we do either one is right. I'm fine with either one, give you the same answer. If you do the inverse, you're solving for x there. It's kind of like you're dividing by a on both sides. You're doing the inverse, really, right? You do the inverse times that. Or when we do RREF, we put the whole thing in there, including the answers on the right side. RREF is a one-time the whole thing, even with the answers on the right side, just does the whole thing, give you the answers. Either way, answers on.
The same instead of doing the inverse?
Yep, same exact answer. It's quicker. You don't have to type two matrices in and everything. Okay, 23. Are you guys on the exam? I'm sure. I don't exactly remember, but I'm pretty sure. So how do you do that? So first thing is you got to find the inverse. Because remember, it says the message was encoded by the M, so you decode it with M inverse. Remember that way of coding, decoding? So you got to find, that we talked about last time. So you got to find M inverse. So whatever that comes out to be, your calculator will tell you, You get your four numbers from your inverse matrix, and then you just take them and one at a time multiply by the matrices you've got, the 119, 189, and then you multiply it by the 153, 288, and you just keep going down the line. Just multiply on your calculator the inverse, the M inverse times each of those, and you'll get something. What's the first one? It's there on the practice exam. What's the answer to the first one come out to be? Or I got it right here. The two numbers comes out to be.
14, 15.
Is that what it is? Yeah, 14, 15. Okay, and then you got to convert those to letters. Now remember how we had the letters? A was 1, B is 2, C is 3, D is 4, E is 5. Write this out if you need to. A, B, C, D, E, F, G, H, I, J, K, L, M. So 6, 7, 8, 9. Nope, there's no 10 there. 10, 11, 12, 13. M-N-O, P, Q, 14, 15, 16, 17. So 14, 15 is N-O. That's N-O. That's no. And then just keep going.
So we'll be decoding, not encoding?
Yeah, we're decoding. Yeah, exactly. That's what they said. They said decode, right?
On the test, though.
Yeah, be decoding on the test. That's right. Decode. Make sense on that? So you just take the inverse of the matrix, times each of those, turn them into letters. All right. Guys, that's a lot of the battle. Always was for me, is recognition. How do you recognize these are not the annuity formulas? Remember all those annuity formulas I gave you? These problems are not, now they're going to be more mixed up on the real exam. They're all mixed up. You could have the very first problem be one of these. How do you know this is not an annuity? What's the key mark of an annuity problem? Payments. There's some kind of regular payments building up to something or tearing something down, right? These are not payments, right? Look at 24. $1,000 put in the bank. Let it sit. 6 years. We're not making regular installments to the bank. We just put $1,000 in one time. No payments, right? Number 25. 10,000 grows one time, right? Not regular. 6% compounded daily. Nothing about payments regularly, right? There's growth, but there's not payments. We're not putting more into the pile. The pile's growing on its own, but we're not adding to the pile with payments or taking away from the pile, right? None of these have payments, do they? So they're not annuity. So then what are they? Well, they're the one other four. You have four formulas at the top. 3 of them are annuity. We talked about that last time. And the fourth one is the compound interest, right? And how did I put that? I gave you and I told you the new form I'm going to give. It's going to be A equals P, 1 plus R over N to the NT, right? On the practice exam, I changed it. I made this part just be I, and I made this part just be N, because I used to teach it that way. But this is the way I showed it to you in the homework this semester. And I will put it, and this is exactly how it looks on the real exam that you'll take on Tuesday. It's the one you're used to. All right, so then you just plug in. 24 is just plug in. 25 is just a plug in. No big deal, I think. 26 might be worth a minute of our time, though. How do you do, oh, wait a minute. No, 24 is easy. 10,000 grows to 10 years. Oh, no, 25 is worth our time, too. Yeah, 25 is a little tricky. Did you see how to do 25? So let's do 25. 10,000 grows to 21,589.25 in 10 years. So, okay, the 10,000, what is the 10,000 there? Is it A or P? It's P, it's the principal. It grows to be the 21,000. So the 21,000 is the A. 21,589.25. The P is the 10,000. 1 plus the R is, well, we don't, that's what we're trying to find. It's not going to be multiple choice on the real exam. I don't know why I made these multiple choice, but I was just probably in a hurry. They're not multiple choice on the real exam. R over N. Now, what is N? Yeah, N is number of compoundings per year, right? And there it is, annual compounding. That means once a year. N is just one. And what is T? 10 years. So there's my equation, right? Now, do you know how to solve that for R? That's not easy at all. First, divide by that 10,000. Get that 10,000 off of there. I think that'll make it 2.1589. 25, just move the decimal way back. This is 1 plus R to the 10th, right? R over 1 is just R. 10 times 1 is just 10. Good. You've done some practice. Yeah. So does everybody see that? How do you solve that for R? You got to raise both sides to the 1/10 power. Did you see that in the homework? In the practice exam, and we did have it in the homework as well. Yeah, 1/10 power. Boom, cancels that out, and you just have 1 plus R equals whatever that number is. Then just subtract 1, and you've got R. Is that good on that? And then I want to look at 27. If you got that down okay. 27 is... Okay, find the amount that should be invested now to accumulate the following amount if the money is compounded as indicated. So, 26, I'm sorry. 27's not special at all. It's 26 I want to make sure I show. Yeah, so for 26, how do you find, what does it say, APY? I kind of erased it.
Yeah.
APY, yeah. How do you find annual percentage yield, or APR, or whatever they want to call it?
Same as compound, subtract 1 at the end.
Yeah, you put in $1 for 1 year. Are we all good with that? $1 for 1 year. So you just take the same equation you're used to. A equals P, 1 plus R over N to the NT. Put in $1 for 1 year. So $1. And the interest rate is what? Is that 6%? 6% over, and in 365 days of compounding, 1 year. So there's our formula. Plug that in, and then what you do? Put in $1 for 1 year. In step 2, you subtract. Remember that? Subtract out the original $1. When you get your answer, it's going to be, your amount is going to be 1 point, I don't even know. What is it? Let me look at the answer key. 1 point.
06183.
Am I looking at the wrong? Oh, I am looking at the wrong problem. Yeah, thanks. 1.0. Yeah, right. 1.0618. 1831. Whatever. Blah blah blah. Yeah. So you subtract out that original dollar because the dollar became $1.06 whatever, right? Well, we just want the growth. We don't want that original dollar. We just want the growth. That's what APY means. Annual percentage yield, meaning annual, 1 year. What percent will it yield? Will it produce? What will be the percentage growth? So get rid of the original dollar and just give me the growth. So it's 0.06, and then turn that into a percentage, move it 2 places, 6.183%. That's what that account will cause growth to happen by. That's annual percentage yield. All right. We good with that? Questions on that? I think we can finish. We got... So this will be due after exam 1. All right, so how do we graph something like y greater than or equal to x minus 2? Do you remember that kind of thing? How do you graph like a greater than less than question? Now, it's fine with me to use your graphing calculator. It will graph. You can put that in as y1 equals x minus 2. You still might have a little trouble telling exactly where the dots are at because you need to put them on the thing there. So you can just put in y1 equals x minus 2 and hit the graph button, you know, and get the graph. That's fine. I'm just going to show you the, if you want to just do it that way, it's fine. I'll show you by hand with slope. Remember the slope thing? So remember you start at this number out here, start in the middle, and negative 2 means down 2. So that would be a dot right here. Let me slow down a little bit. Remember that from your algebra days, those happy algebra days? Are those happy days? Okay, so whatever number's out here, that's where you, if there was a +3 out here, I would go up to +3 on the middle line. It's always on the middle line. Remember, it's called the y-intercept? Not going to quiz you on the names. But whatever number is off to the right, that's your first dot. And it's always on the middle line. If it's -2, it's down 2. If it's +7, it's up 7. That's your first dot. And then, how do you find the other one? Remember where the slope is? Where's the slope? It's the 1 over 1. It's whatever's in front of that x. The fraction in front of x. If there's nothing, it's 1 over 1. So that's rise over run. Remember that kind of thing? So from this dot, from your first dot, we're just going to go up 1, over 1. And there's the next dot. And then you just connect the two dots. Does that make sense what I did? So my first dot was at down 2, whatever number's off to the right. The next one you go up 1, over 1. Rise over run. Put another dot. Connect your two dots. That's your line. Now, how do you know if you want to shade? We're going to shade above the line or below the line.
You input one of the points.
Yeah, there's the check a point method, and if you're good at that, feel free. I found it's easier for students just to simply look at what the y is saying. Don't look anywhere else. What is that saying? Y is, what is that symbol saying? Y greater. Y greater. Here's the y-axis. There's the line. Where are the greater y values? They're up here, aren't they? That's all you got to do. You don't got to check any points or anything. If it said y less, then we'd shade below, wouldn't we? That makes sense on that? That's all you got to do. Let me go. Okay, so on this one, even if you're using your graphing calculator, which is totally fine, you're going to need to do some by hand manipulation first. The reason is because y is not alone, huh? You can only put it into your graphing calculator. It says, what does your graphing calculator say? y1 equals. So you got to have y alone. So we're going to have to get y alone here first. So that's always the first step. First, get y alone. So just jump the 4x over. Well, I'll put it in the front. Jump the 4x over. Becomes a negative, right? When something jumps to the other side, I really just subtracted 4x from both sides. Is that good so far? And now divide by 4. So y is, what's that, negative 1x plus 4. Am I going too quick? Good with all that? So I got y alone. Now we just do the regular stuff. We just find our two dots. Where's our first dot going to be?
4.
Yeah.
4y.
Start here, up 4 in the middle on the y-axis. That's right there. Am I going too quick? Is that good? So you take the equation. You got, even if you're going to use your graphing calculator, you have to get y alone. Then you can just type this in to your y1. So if you want to just type this into y1 and ask the calculator to graph, that'll be fine. But you'll have to go back and find the two particular dots. It might be hard to, I don't know, maybe you can just trace it along the graph. It'll tell you the dots it's at. I never tried that with graphing calculator. So it's just as easy by hand, I think. Just get y alone, and then that's your starting dot at up 4. And then how do we get to our second dot? Remember what's in front of x? We need to make whatever's in front of x look like a fraction. So I put that over 1, don't I? Now it looks like a fraction. So this is rise over run. That good? To there. So that means I do what? You had down 1 over 1. Does that make sense there? Because the negative, you rise negatively means go down. So to rise -1 means to go down 1 over 1. So there's my other dot. And then we can just connect the two dots. There's our line. See what I did there? So I started at the up 4, then I went down 1 over 1. Connect the two dots. Now, is the shading going to be above or below? Look at the last line when you had y alone and ask yourself, what does that say? Y is less. It's below. Yeah, the lesser stuff. Still, it's down below that line, huh? Is that good on that one? Questions on that? So we got to get y alone before we can do any of this. Okay if I flash that off? Okay, try that one. Can you see it? Yeah. So it's so 2x minus y less than 8. So go ahead and solve for y there. Let me give you just a second. I want to see what you remember from your algebra days. Everything, right? Perfectly. There's a little trick in this one that I'm sure you saw in algebra, but you might not remember. Let's see if you remember. Get y alone there on that. We good? So grab that 2x and move that over. Is that good so far? When that 2x moves over, it becomes a negative 2x. And now I got to get rid of that negative in front of the y. So what do? Divide through by -1. Good. Some of you guys remember, you got to turn that symbol. Remember? So when you divide by a negative, you must flip the symbol. Yeah, that's that little algebra rule. Yeah, so you got to turn the symbol. Whoops, I got it the wrong way. So, and what happens here? Negative over negative? Positive. Positive over negative? Negative. Notice how the number on the right, I don't want him to be a fraction. But I like to keep the one next to the x as a fraction because I need two pieces of information, rise and run, don't I, from the x. Okay, so is that good? Can you graph that now? Where's your first dot? Yeah, so start down 8, right? That'd be down right here. Start down 8. And then do your rise and your run. This is rise and this is run. So that means go up to 1, 2, over 1 right there. Now I have one other trick, probably some of y'all already know it. What kind of line is this one going to be?
Dash.
It's going to be a dashed line. Yeah, why? Because it's y less than, it doesn't have the equals bar. So when you just have greater or less and you don't have the equals bar, the line has got to be a dotted line instead of a solid line. So for these kind, it's a dotted, and I'll show you how to do that on the Math Excel. It's a dotted line for greater than, less than, without the equals. You don't have the equals, it's a dotted line. Why? Well, think with me. I think you know if you think about it for just a second. What if this problem said equals, y'all? What if it said straight equals? I would just graph the solid line and there'd be no shading at all, right? That's what you did back in your algebra days. So that tells you that the equals part is just the thin line. And the greater than, less than, that's what produces the shading, greater above, less below. So if you think about it, there's the shading above or below, and there's the line solid for equals, and dotted, meaning not there really, for if there's no equals. So that's why when they say strictly what? Why erase it? Greater than, strictly greater than, what that means is they want the stuff above the line, greater stuff, but they don't want the line itself. Right? If they wanted the line, they would say greater or equal. The equal would be the line itself.
Is that the lesser side? Left?
What's that?
Wouldn't the greater side be shading the other side?
Okay, yeah, don't think right, left. Don't think right, left. Good question. I forget that. Remember, it's y-axis.
Oh, wow.
Remember, we're thinking above or below. Don't think right, left. I know when the lines are almost vertical, people just kind of automatically think right, left. Don't do that. We didn't get x alone, we got y alone. Because we got y alone, when we say greater, we mean greater on the y. Or less, we mean less on the y. No matter how vertical that thing is. Well, unless it's perfectly vertical. Different story there. But yeah, see the y-axis? Here's the higher y values. Here's the lower y values. So it's higher y values. Think above or below. Don't think right, left. That makes sense? Because we got y alone. Above and below is our thinking. Is that good? So there it is. All right, so here we have y less than 9. We don't even have an x. What kind of line is that going to be? I think you already know, huh? Yeah, it's going to be either straight sideways or straight vertical. How do you know which one? Well, it's got to hit the y-axis, huh? So here's the y-axis at 9. So if you're going to hit the y-axis right there at 9, you got to be a straight line like this. And it's got to be dotted because there's no equals, huh? Does that make sense? Hits the y-axis at 9. It's dotted because it's not less than or equal. It's just, remember, if you have the equals bar, you have a solid bar, you're a solid line. No solid bar, you're not solid, you're dotted. And am I going to shade above that or below that? Y less. Whoops, I just erased it. Y less. So shade below. Yeah. So those are quick. Those. Right, so x less than or equal to -5. That's going to hit the x-axis. Oop, over here, huh? -5, hitting the x-axis at -5. And which side am I going to shade? Now, this is the one and only time we do think right, left. Because we only have x, right? X is alone, not y. So we do think right, left. What does that say? X is what? Less. Where are the lesser? Here's the x-axis. Here's lesser x values, greater x values, huh? This way, isn't it? The lesser x values. That makes sense on that. Pretty easy stuff. Not too bad, right? We'll finish that up later. It's not even going to be due next week. We've got more to do. All right, so we will really take our exam on Tuesday. Study hard. Make good use